Hello, I'm Jack Talboys, a junior data scientist from Mango Solutions. And today I'm going to be kind of introducing you to ggplot, kind of giving you an idea of what typical ggplot code looks like, as well as trying to give you a little bit of a look inside my head as to what goes on while we're actually creating a ggplot. So of course, to actually make a plot, we need some data, and I'm going to be using data from Tidy Tuesday. So if you've not come across that, it is a really cool project where every week a data set gets released on the Tidy Tuesday GitHub, and then people can make a visualization with it and post it to Twitter, for example, with hashtag Tidy Tuesday. And it's a really good way to get your visualizations out there and get recognized. So there's a really easy way to read this data into R. So we just need the Tidy Tuesday R package. So if we load that in and then use the function ttload. So here X is the year we want. So I've already had a look through all the data sets, and there's some really interesting ones. Some revolving around sport, some revolving around rap music. I was tempted to do, but I chose to go with week 14 from 2020, and that is revolving around beer. So when you load in the data using this tt_load function, there's actually 4 different data files. So now if we look at the object, there's kind of a list of the 4 different data frames. So we're going to be focusing on this beer_states one. So we're going to put that into its own separate object. Now, I will be honest, I have prepared for this a little bit, and what I know kind of from experience is that we do need to do a little bit of data prep to start with. So we're just going to library the dplyr package to make those dplyr verbs available to us. Then we're going to use the pipe. So I know Jeremy did a presentation at the Brighton R, kind of introducing you to the tidyverse, and hopefully introduce you to the pipe. So if you're kind of reading that code, you want to read that as kind of an as-then. So we're taking our beer_states data frame from that beer object we created before, and then we want to filter it. So what I know is that we want to remove all the NAs from the barrels column and all the zeros as well. So to remove all the NAs, we use the exclamation point to say we don't want this. And then we use is.na and then barrels, which is the name of the column. And then inside filter, that comment is like an and. So we say we also don't want any occurrences of barrels. So we want all the occurrences of barrels that are not equal to 0 as well. So if we run that and then go down to our console and take a head of the states, you can see we've got these 4 columns. We've got the state, the year, the number of barrels, and then the type of beer production. Cool. So now we've pre-processed our data a tiny bit. I tried to find kind of data that required the least pre-processing. We can actually go and work on our ggplot. So to do that, of course, we'll need to library in ggplot2 package. And then all ggplots are going to start the same way, or most of them are at least. We're going to use this ggplot function from the ggplot2 package. Slightly confusing, but yeah, that's the function you're always going to be using. So the main argument that we want to be passing through is our beer_states data frame. So if we just run that line of code on its own, then we're going to get a blank plot. So you can see that in my plot viewer, It's just like empty gray background. So it's kind of like initialized it. So we're going to build on top of that essentially. So that means that we need to supply some more arguments. So the next part is telling the plot what we want on our axes. So what we want to map our variables to on this plot. So it makes sense that we're using the mapping argument. So to use this mapping argument, we need a helper function from ggplot called AES. And then inside this AES function, there's all kinds of different options. So we can set our x-axis, our y-axis, we can set a variable we want to map to the color, for example. But now we're just going to map our x-axis to that year column and our y-axis to the number of barrels. So all we say is x is the year, and then y equal to the number of barrels. So we don't need to quote column names here. ggplot is part of like the clever tidyverse, which uses this tidy evaluation, and it understands what you mean just by passing it through without quoting. So now if we run that code, we can see that our plot's changed quite a lot. So it's still essentially a blank plot with no information on it, but now we've got our two axes set up. It's taken the names of the columns as the names of the axes, and it's also given us some axis ticks that kind of correspond to the ranges of the variables that we've passed through. So to actually plot some data onto this, we need to apply something called a geom. So a good place to start when you're thinking about kind of what sort of geom should I use is the ggplot2 cheat sheet. So I've loaded it up here already, and you can see that it kind of really well describes kind of all the different geoms and the cases where you might want to use them. So if you've got one variable, you might want to use a histogram, so you use gem_histogram. And then when you've got two variables, you've obviously got different cases. So you've got two continuous, two discrete, for example. So if we go back to our plot, we've currently got two continuous variables, but we kind of know that year is actually categorical. So if we have a look again at our ggplot2 cheat sheet, we can have a look at the continuous ones to start with. And geom point seems like a good place to start. Kind of one of the more simple geoms from ggplot2 will just produce a scatter plot. So to add this scatter plot geom to our plot, much in the kind of a similar way we use the pipe when we're using dplyr functions, we can use the plus with ggplot2 plot. So all we do is add a plus after our call to ggplot, and then we call out to geom_. So now when we run that, we actually get some data plotted. And you can see like the underlying plot is exactly the same as we had before with the scale of the axes and the labels. All it's added on top is the actual plot of our data. So this looks a bit strange. We've got kind of one outlier each year. So again, we're going to use a little bit of dplyr just to investigate that and see what's going on there. If we take the states data set and pipe it through to the arrange function, so think of that like sort, and then we can pass through the column we want to sort by. So because we want barrels in descending order, if we take the negative of barrels and run that and have a look, we can see in the state column, instead of having an actual singular state, we've got the total. So to avoid all our plots having these, obviously not outliers, but this kind of extreme points on each one, we want to remove that from our data set. So we'll delete that call to arrange, and we want to kind of overwrite the current state of our states data frame. So to get rid of this, we're going to use that filter again. So we want all the observations where state is not equal to total. So we run that. So if we go back up to that arrange call, run that again, you can see now we have no rows with totals. These are all states. So it would make sense to put that call before our plot. We could even chain it onto initial filter to get rid of the NAs and zeros if we were really clever. But for now, that would be fine. So now if we run this same plot again, we can see we kind of get a clearer look at the distribution of the points. So one thing that I think is really important to change in this plot at the moment is our year axis. So you currently see you've got like 2007.5, 2010, 2012.5, when we know that our data is kind of 2008, 2009, 2010. So because it's categorical, we want to convert our year column into a factor. So we could do this in the underlying data, but that may not be ideal. So actually doing it just inside the plot is really easy. All we have to do is surround our call to year in that AES function with the function factor. So all that does is kind of takes the factor version of year whenever we use this plot. So now if we run that, you can see it's changed the label of the axis because it takes that explicitly from what we call an AES. But it's also sorted out our axis ticks. So now we've got 2008, 2009, 2010, etc. Okay, so how else can we improve this plot? Well, let's think about these data points down the bottom here. So you can see there's a lot of data points on top of each other. Because they're all in a line, we can't really tell exactly how many data points there are. So if we go back to our ggplot2 cheat sheet and have a look at this geom_jitter function. So what that jitter function does is it's essentially the same as geom_point, except what it does, it adds a bit of random noise to the plot, to the points. So all we're going to do is replace our call to geom_point with GMJitter. And then if we have a look at the help file and have a look at the arguments, we see there's this width and this height. So that controls the amount of random noise that you want to add to your points. So if we think about our plot, if we start moving points about vertically, then that's going to change our kind of perceived value of like the number of barrels produced at that point. So we only want to mess with it vertically. So in this case, we want our height, so like the vertical random noise, to be set to 0, and width. So this is kind of where the experimentation comes in. So if we try a value of 0.5 to start with, for example, and take a look at that. So you can see from that plot that random noise was too much. It's kind of blurred all the points from the different years. So if we reduce that to something like 0.1, for example, you now see that we can clearly see which points belong to which year, but they are still a bit too close together. So if we increase that a tiny bit more to 0.2, and yeah, I think that is the best solution there. We can still clearly see which points belong to 2008, for example. But there's also, we can see that there's a lot higher density down below than there is up the top. So a really simple way to improve your plots next is to just add some labels. So there's a few ways you can do this. So there's functions xlab and ylab to explicitly add the x labels and y labels. But there's also an overall function called labs, which you can specify inside labels for all the different parts of your plot. So in here, if we want our x label to be year, we want our y label to be something like year production in number of barrels. And then we can add a title, which would be something like beer produced in each state by type and year, for example. So I made a little error there, so that needs to go inside of those quotes. And then we need to replace that bracket at the end. So now if we run this, we've very nicely labeled our plot so that people know what is going on with it a little bit more. So kind of thinking about this data now, yeah, we've been able to use GMJitter to see what's going on down the bottom a little bit more. But you can see with this kind of long tail of the data, so that is for your observations, kind of the higher up you go, it kind of lends itself quite well to sitting on a logarithmic scale. So if you ever want to mess with the scales of your ggplot, we're going to be using these scale functions. If I just type scale into the console, it will auto-complete, and you can see all these like scale underscore alpha, scale underscore color. So that's when you're messing with kind of gradient and color. So we're going to be messing with our y-axis, because that's what we want to convert to logarithmic. And you can see we've got this scale underscore y underscore log 10. So all we do is, again, we keep adding to our ggplot. And we add this scale underscore y underscore log 10 function. Now, when we run this plot, you can see it's giving us it in a logarithmic scale. I think the only thing I don't like about this is the scientific notation that's used on the labels. But luckily, there is a good way around that. So inside the scale underscore y underscore log 10 function, we have an argument called label. And that controls how your axis ticks are labeled. So in this case, we want to remove it from scientific notation back to just like the raw number. And because it's quite big, we want to have it like comma separated. So for a million, for example, there'd be 1, 3 zeros, comma, and then 3 zeros. So the way we can do this is passing through the comma function from the scales package to this argument. So all we're going to be using from this scales package is this one comma function. So instead of librarying it in at the top with the rest of them, we can just call out to the scales function, scales package, sorry. And then if we do double colon, we can access all the functions from the exports without having to library in the package. And then I don't think it matters whether you put brackets at the end of the call to this function in this case or not. So now again, if we run this plot, you can see it's much nicer. We can kind of, someone that was non-technical would be able to understand that this was a non-linear scale. So now it's time to look again at our actual kind of data that's contained in this plot and think about whether this kind of scatter plot version is the best. So when we think about it, actually it doesn't lend itself very well because of like the high density of points, and we can't really tell about any distribution. So something that would be good in this case, I think, is a box plot. So we've got our kind of categorical data along the x-axis and then continuous along the y. So I think it lends itself quite well to the box plot. Luckily for us, in terms of adapting our ggplot, making it into a box plot is as easy as placing this call to geom_jitter with a call to geom_boxplot. And that's all we have to do. So now, if we run that code again, instead of our scatter plots, we've now got some box plots, which kind of give us an idea of how the median is changing over time and gives us an idea of which points are outliers. Okay, so now if we look at our title, beer produced in each state split by type and year, it's currently not clear like which data points belong to which type. So if we have a look, so if you call this unique function and pass it through a vector, it'll give you all the unique elements of that vector. So we can pass through beer underscore state dollar type, and we can see we've got 3 different types of beer produced. We've got the barrels that are drunk on premises, the barrels that go into bottles and cans, and the barrels that go into kegs and barrels. So if we want to split this plot by the type, all we have to do is edit this call to mapping in our initial ggplot function call. So all we do is add another argument. So we might want it to be the color or the fill of the ggplots. So if we specify we want the fill of these boxplots to change, again, like we've done above, all we need to do is specify the name of the column there. So we want it to be type. So now when we run that, we can see that it has given us a nice little legend on the right-hand side. And for each year, we have 3 separate box plots, 1 for each type of beer produced. So in my opinion, this plot is okay, but it's a bit too squished. So I think something that would be good to look at is something called faceting. So that's where instead of having it all on the same plot and splitting by, for example, color or fill, we have 3 different plots, and each one is for each type of beer. So we're going to remove this fill call from the mapping function, and instead we're going to add on to the end of our ggplot call this facet grid function, and we say we want the rows to be split by the type of beer produced. So we have to wrap the call in type with this function var, so it knows that it's a variable from our initial beer underscore states data set. And then if we run that and kind of zoom in on our plot a bit to get a better look, you can see that we've got 1 plot for bottles and cans, kegs and barrels, and on premises. But they've all got the same scale, and they all share the same x-axis, which can be really useful at times. So the only kind of major pattern I'm noticing here is there's like a slight increase in on-premises as we kind of go along. So that would be something that would be interesting to annotate. So we can annotate our plots using the geom underscore text function. But if we just do geom underscore text and then pass it through like an x coordinate and a y coordinate, then it will put it onto all of these 3 plots. So that's kind of not what we want. We want to have it just on this bottom plot. So for that, it's a bit trickier, and I'll admit it's kind of took me some Googling to find out the answers how to do this. But it means we actually need to create a new data frame. So this data frame is just going to have 1 row. So it's going to have the x coordinate that we want, text to be at the y coordinate. We need to specify the type, so in this case, on premises, so that it goes on to just this on premises plot. And then we can specify the actual label to be, for example, like an increase in recent years. So if we kind of store that data frame and take a look at it, we can see it's just that 1 row with the x coordinate, y coordinate, type, and label. And then we can pass that through this geom text function. So we still have to pass this data through this mapping argument and then use that AES helper function. But this time we're going to say that x we want to be equal to x, so the x column from our data frame, the same with y, and the same with label. So the main difference is that we want the data this time to come from our separate data frame. not from our kind of originally passed through data. And you can see this, and you can see it's added that text in just on the on-premises plot at the X and Y coordinates we specified. So because I've only got half an hour, I kind of already knew the perfect coordinates to put it in. But yeah, like that's something that you can mess around with. You can maybe mess around with the size of the text by using the argument size. So say we wanted it to be size 3. You can see that's made it a lot smaller, for example. So something that will make our plot a bit more fun, this is a bit boring at the moment, is adding some color. So we can color our box plots by passing an argument through inside this gm_boxplot function. So all that requires is passing through to the fill argument, but this time not inside mapping, just inside the overall function. And say we want to try and make it look kind of like a nice private bit. So it's kind of orangey, that'll do. So if we just run that, we can see we've got this lovely shade of orange for our box plots. So there's loads of kind of little tweaks you can make to your ggplot to try and get it perfect, just how you'd like it. So for an example of kind of all the things that you can control, if we take a look at this theme function on ggplot2, this is how you modify all the components of a theme like it says there. And if you look at all these arguments here, these are all the things you can control individually. So like the axis ticks, there's like an overall class, and then you control the x-axis ticks, y-axis ticks, and then like the top and bottom, left and right ones. The lines, the legends, the panels. There's an awful lot that you can control. Now, kind of messing about with all these here isn't very practical in half an hour. So something that's really useful is that ggplot has loads of preset themes that can make your plots look a lot more effective really quickly. So I feel like we did with the scale, if we look at all the theme functions exported from ggplot, we can see that there's quite a few. So I like quite a simple look. So if I go with theme minimal, you can see it's removed that kind of, not horrible, but that kind of not the best grey background. It's made the plot a lot simpler. I feel like it's a lot more focused on the data now. And if we just zoom into that, it's still got our labels alongside, nice, and our text that we added. Okay, I think my time for kind of trying to show off ggplot is about up. I hope it's been useful. I hope you've learned something. I'll make all the code for this available on GitHub. I think it will be, I think it's Mango the Cat / Brighton R ggplot demo, I think it's called. It'll be something along those lines, so I'll make that available for you. Any questions about what I do or about this talk, please get in touch. You can find me on GitHub, or my email is talboys@mango-solutions.com. Yeah, I hope this has been useful. Thank you for having me. Hopefully we've got some time for some questions now. Thank you.